Hi, welcome back to CFD Simplified. In today's video, we'll be diving into the circuit board cooling case in OpenFOAM. This simulation models heat transfer and airflow distribution over electronic component, something crucial in electronics cooling design. Okay, so let's start the tutorial. So we have to go to first to foam tutorials, then we will go to heat transfer, then we will go to buoyant pimple foam, no, buoyant simple foam, and here you will find the circuit board cooling. Okay, so let me copy this to my home directory. Okay, is it here? Circuit board cooling. All right, so now let's go, and as we always do, go and check the system directory. Okay, you will find block mesh stick, and then you will find baffle stick. Okay, so what is this baffle stick? Okay, so baffles, basically we are just making it to make as an patch. Okay, patch in this in the mesh. Okay, so that it can work as a circuit board. All right, so that's why a baffle, create baffle stick has been made. Okay, and if we'll go to baffle 3D region, you will find the, because what let's go to FE solution first. Oh, what has happened? FE solution. Yes. So for the baffle region, they have added a separate the separate solution, like separate scheme. All right, that is the thing. Okay, so first let's copy this 0.org to 0 directory. It's been done. Now we again have to go back to our tutorials, because we have to make one try surface directory to okay, so we have to make this try surface directory, so that we can we have to bring baffle's geometry here, because baffle has been previously made in the in our 3D software. All right, so we have to first bring it down here. Okay, so I'll just copy this path, and then I'll go back to our tutorials, foam tutorials. Before we continue, if you are working on a CFD, OpenFOAM or engineering simulation project and need personalized help, I now offer paid support and consulting. Whether it's setting up your case, debugging issues, or developing custom solvers, I'm here to help you move forward faster and more confidently. Just reach out via email in the description. Let's make your project a success. Okay, so all right, so we will be doing this. So now we will go to the resources directory, then we will go to geometry. Okay, then you will find here this baffle 1d.stl and baffle 3d.stl. okay, so we have to copy both of them, cp-r baffle 1d baffle 3d, and we will paste our path wherever we have to paste it, and enter. Okay, I will clear the terminal, press CD, then again I will go to circuit board cooling, I will go to constant, then I will go to try surface, and here we are, our files has been copied here. All right, so let's go back. Okay, now the next thing is we can run the block mesh. Okay, we can run the block mesh. So block mesh has been ran, then we will make the baffles. So to make the baffles, we have to type create baffles, and to have that changes in the mesh, okay, we will have to give override. Okay, so it has been done, and now we will simply run the solver. Okay, so the name of this solver was control dict. To check the name of the solver is bio and simple. Okay. Now I will go back and I will paste the name of the solver. Okay, so it has started running. It will take some time to complete, and after that we will post process it in ParaView to check the results. Okay, all right, so the simulation is complete. I will clear the terminal. Here is the time steps. Now I will make .foam file, and I will go to, okay, now I will press apply, and this is our domain. So first we will go to solid color and choose wireframe. So this is our mesh. Okay, so first with the help of the block mesh, the rectangular domain has been made, and with the help of with the help of this create baffles, we have made the baffles inside it. Okay, snappy hex mesh, why we have not used? Because snappy hex mesh, what it will do, it will cut this the shape from this from the rectangular mesh. Okay, we don't want to cut it. Okay, we want the whole rectangular mesh, and inside it hollow portion will be there, and there this baffle which is being considered here, this will be placed. Okay, so this we want. So that's why here in this tutorial they have used the the baffle, create baffles part. Okay, so that is the thing. All right, so let's select the surface and let's select the temperature to check what we are getting. Okay, so this is at 500 seconds, and if we will just go on to 2500 seconds, so this is our case. Okay, we have to go to wireframe only to check the case. Okay, so you can see that whole this is being considered as the board, and this is being considered as the electronic component which is being heated. So yeah, like it wanted to show that how the this like how the effect of the air is being there. Okay, like how the air passing through this is being heated. Okay, and that will be happening. Okay, because some cooling arrangement will be there. Okay, so for example some fan is put here. Okay, like in our workstations or in PCs, and that fan is blowing air to cool it down, and from here the exhaust will be there. Okay, the that hot air will be coming outside. All right, so that is the thing, that is this temperature will be showing that how the air will be flowing. If you can go to surface, you can see that the flow, you can see that which is happening here. Okay, you can see that the flow which is happening here. Okay, here you can see. All right, we can okay, and this is there. Then this is q is like what is the heat which we are supplying, okay, to the surface. So it is like it is in the range of this one. So you can see that this much heat is being supplied to this to the baffles. All right, then why partial? Because heat is being supplied to this one only, not the whole domain. Okay, that's why they have written it as partial. Now we will go to check to the velocity, and here you can see the velocity pattern. Okay, we'll just go to surface again, and this is the velocity, how it is being flowing. Okay, how it is being flowing, right? So this is the thing, this is the part. All right. So like this, like basically what they wanted to show, that you can with the help of the BioEnd simple form solver, if there is an any circuit cooling thing, you can just circuit cooling case which you are solving, which you are trying to solve, you can solve it with the help of that one. Okay, you can solve it with the help of that one. All right, that is the part. That is, otherwise, you have to check many solvers whether it will be working or not. Normal solvers may work, but yeah, you have to make many changes there. You have to make the boundary conditions and all those things accordingly. So if something is there, or okay, only you have to make, only then you have to focus only making your case, and you don't have to work on the solver part. All right, so that is the thing which I wanted to discuss. Okay, so yeah, and that's the circuit board cooling tutorial in OpenFOAM. We saw how the solver handles conjugate heat transfer and airflow over a circuit board. This is a great starting point for anyone working on electronics thermal management. If you found this helpful, hit the like button, subscribe, and check out the description for more resources. Thank you for watching.